pointed out that if you drop an object on the Earth, okay, you're claiming that the object's effectively just sitting there on
Nope.
the Earth.
Nope. Nope.
Go ahead.
That's not what I'm claiming. What's that?
Is the object falling or not?
No. There's no downwards acceleration is my claim.
Is the object falling?
What, falling, like physically moving downwards through space?
Yeah.
Nope.
Okay, so it's just sitting there.
Nope.
Then what's it doing?
Losing momentum. So the position here is that everything within the Earth is in motion with the Earth. So when I release an object, from that moment I release the object, it loses the momentum it had.
Okay, so here's the question. When I use interferometry and I measure an object falling to the ground at a single location, the rate that is measured with lasers changes at the same location throughout the day. Okay? So then you need to explain to me, how is the object falling at different rates at the same location if it's actually the Earth moving up?
Okay. So before we even get to any of that, right, I'm going to screen share here. No. What's it? I'm addressing it. Right? What I'm going to show people is your interferometry. Right? Can you see the screen? What's it?
I cannot see a screen, no.
Right. Well, for the people watching, here's this video. Right. So what we have in front of us is a reference frame, a box. In the reference frame, we have two rulers within the box. Now, using interferometry, you would only conclude that it's the ruler that's moving. However, in any given situation or scenario here, I'm moving both one and the other simultaneously. So in one scenario, I'm moving just the ruler. In the other scenario, I'm moving the box. And in the other scenario, I'm moving both. How are you going to establish physically what's actually moving? The method of understanding that something accelerating is or being in motion would be the displacement and accelerometer. So if something is falling downwards, that being a bottle with gas liquids in it, right? And I see no displacement of the gas in the liquids. Why am I not seeing the gas in the liquids displacing if it's accelerating? So things fall at different rates at the same place. So if I get a marble, the same marble, and at different times of the day I drop it, and apparently it falls at different rates. I need to see that first and foremost. But however, there could be all sorts of factors to account for that: electrostatics, magnetism, air resistance, air density, pressure, moisture. There's loads of variables that I could have to get through before I establish that. However, there could be all sorts of factors to account for that: electrostatics, magnetism, air resistance, air density, pressure, moisture. There's loads of variables that I could have to get through before I establish that.
Okay, so that would be displacement then, right?
What do you mean?
Well, if there's a change in the measured rate, then there would have to be some form of displacement.
No, the displacement.
There's uniform motion up.
The displacement's in regards to different matter, so gas, liquids, and solids. So in my example, when I drop the bottle with gas, liquid, and solid, not only that, an air bubble rising and something sinking within it, all that motion ceases, and there is no displacement of the gas and the liquid. So why is that happening?
Okay, the fact that there's a buoyant relationship with the medium is completely non sequitur. You're saying, you just invoked electrostatics and stuff, which is funny, right? So you're saying that there are external variables that will change the rate at which we can measure objects falling. But you know that there's actually no acceleration, even though we're measuring a change in it.
There's no downwards acceleration. There's no downwards acceleration.
You realize this is just an unfalsifiable claim?
What? No, it's not. What's it? If I accelerate a bottle downwards, physically accelerate it downwards, I see displacement. I witness displacement and I see an inversion of buoyancy and density. That's what happens under conditions of acceleration with gas, liquids, and solids. When I let the bottle go, I see no displacement, no gas and liquid displacing, buoyancy and density not inverting, ceasing to be. Why? What's it?
I just explained to you there is a buoyant relationship, and that would be stronger than the weak.
What do you mean?
What
do you mean? What do you mean there's a buoyant relationship? A buoyant relationship between what's it? Because in the bottle, well, in the bottle, the relative density disequilibrium has been claimed. Relative density disequilibrium would the motion of buoyancy and density would be present regardless of whether it was in free fall. If it's only related to materials within a medium, I should still see the air bubble rise and the thing sink. But you're still not answering the question. What's it? If I physically accelerate the bottle downwards, I see displacement of gas and liquids. Now you're claiming there's downwards acceleration, but there is no displacement of the gas and liquids. Why?
So there's a buoyant relationship with, say, the bubble and the liquid, right? And that buoyancy is going to be stronger than the downward electric bias. So therefore, you're not going to see the displacement from the downward electric bias because the buoyant relationship is much stronger. Interferometry objectively refutes this claim.
So you say
listen, dude,
no. Don't step over your claims. Don't step over your claims. What's it? Don't step over your. Are you telling me that you can affect buoyancy with electrostatics?
Of course you can.
So you can invert it then?
Yeah, absolutely.
Where's the demonstrations? Tell me where I can go and see that right now.
Okay, go watch the Last Level documentary.
What's describe the physical demonstration that you're talking about in there?
I use two Gaussian plates. I flip the polarity of the field, and I can cause the objects to go up.
Listen, what's that?
What's that?
What's that? They're still avoiding. What's that? What's that? Using individual pieces of matter and making them change their positions. Know what I'm asking you? What's it? Right? When I let the bottle go and there's a claim of downwards acceleration, why am I not witnessing the displacement of the gas and the liquids?
This is the reality. We have something called linear interferometry. It measures linear motion. If you're claiming that the Earth is moving up it would be measurable with linear interferometry. So what we found out is that objects will fall at different rates, and you had to invoke electrostatics to explain it. Okay. Are you denying that I can take a Van de Graaff generator and make something go up?
No.
Okay, so then do you understand that even though the object's more dense than the air, I can actually make the object go up?
That's fine. Nobody's disputing any of that stuff. Witsit? I don't know what you're talking about, sir.
Well, you asked me how can I account, or how can I basically flip the directionality based on a density tower? It would be the same thing. If you introduce enough electrostatics to flip the polarity of the field, you can flip the direction.
So you've no actually inverted buoyancy and density, so you've no actually got a bottle with water, gas and an air bubble in it, and you're actually flipping the whole orientation and showing us the air bubble now going down the way and the dense material going up the way within the water, or even accelerating it all without displacement. I mean, that's what I'm looking for here. Let the bottle go and the bottle, the gas and the liquid don't displace, they must all be moving towards the earth at the same rate, correct? So when I let a water bottle, if I accelerate a water bottle down the way, the air goes to the bottom and the liquid to the top. But if I let it go, that doesn't happen, right? Are you still claiming that it's all accelerating towards a stationary Earth?
Yeah.
You're claiming uniform downwards acceleration then?
No, it's not uniform.
Well, why is the water and the gas not displacing?
It measurably fluctuates, bro.
So why does the gas, the liquid, and the solid not fluctuate between themselves then in free fall?
A buoyant relationship between the different liquids, the mediums, right? And that buoyant relationship is much stronger than the provable, measurable downward electric current on the Earth. So what I'm invoking is actual facts, which is that I can measure there's a downward electric current on the Earth. I can measure objects fall at different rates at the same location.
That's great.
You're having to invoke my position. Right
no.
Electrostatics will change.
No. That's I'm not using that as anything to do with the vector or buoyancy and density or the pressure gradient. That's no, don't straw man me. Again, what's it? In the vessel, the gas and the liquid in the same vessel contained, right? And I let that go, I see no downwards acceleration, there's no displacement. So it must be accelerating towards the stationary Earth uniformly. Correct?
No.
Wow. So it's not moving uniformly. So if they're not moving uniformly, I would see displacement.
Okay. If there wasn't a stronger force present,
what's a stronger force?
Buoyancy. I've said that 7 times.
Buoyancy's not a force. Buoyancy's not a force. What's it?
Oh, really? What is it?
It's an effect.
Oh, it's an effect of what?
Motion.
And it doesn't result in... No, it's not an effect of motion.
Of course it is. Listen, what's it? If I accelerate a bottle with a gas in it, right, and a liquid in it, an accelerometer, the gas moves towards the direction of acceleration.
Hey, buddy, you just said buoyancy's not a force.
It's not a force.
Enlighten all of us. What causes buoyancy?
Motion.
Motion? So anywhere there's motion, there's buoyancy.
Listen carefully. When I accelerate gas and liquid, the gas moves towards the direction of acceleration. So I can invert what you call buoyancy, right? I can create buoyancy in any vector you decide. So if you tell me I want it at a 45-degree angle going in that direction, I can create buoyancy in that direction. So buoyancy's not something that's itself. It's an effect of motion. That's what a density gradient is.
It's an effect of pressure mediation, bro.
Pressure mediation. Pressure only happens because of motion. Also, again, in free fall, pressure, buoyancy and density, motion vector, density gradients, orientation, all vanish in free fall.
Hey, here's the deal, man. The buoyant, if you want to call it an effect, whatever, it is, of course, an effect of pressure mediation. It results in a force if it's defined as...
It's a result of a force. It's a result of a force. Listen, do you know what a force is? What's a force? What's it?
Well, according to mainstream physics, it's MA, right? But you have to get into what is M.
No, which Witsit's claim of what a force is?
What they say is mass times acceleration. I don't believe in quote-unquote mass. That's actually volume times density. So volume times density times acceleration is what we call a force. Now, actually, to define energy and force and field...
Energy? Jeez, what's energy? I'll tell you, force is motion, right? And energy is motion. A force is something in motion that presses on something else. That's what a force is. Energy and force are not things intrinsic of themselves. Energy and forces are concepts to describe motion. There you go. Simple.
Okay. Motion is a very encompassing term. We have linear interferometry. It measures very precise motion, okay? Precisely measures motion. It's called linear interferometry, which was denied to even exist for years because it destroys the globe. It exists. It's provable. If the Earth is moving upward, you would be able to detect it with linear interferometry.
How? Explain.
Okay, so you take lasers, right? You have light that's in the same phase, you split it, making sure it's in the same phase. If there is motion, then it's going to cause a displacement or an interference pattern in the light, because in one direction, the light's going to have to travel further due to the motion that's in its environment, where you would get an interference pattern detecting the motion of the Earth.
Well, the air? I mean, how would it detect the motion of the Earth if it's attached to the Earth, moving linearly with the Earth? How does that work?
Wait. So you think if I shoot light up above the surface, that it's all attached to the Earth in all directions, even if it's in a singular direction?
No. When you say linear, do you mean linear like any direction in a straight line?
Yes.
Right. So when you're using that to detect apparent downwards acceleration, what are you using? Are you dropping objects?
No, you don't have to drop an object. It's just using light, right? It's using lasers, and we have perpendicular light. Okay. If there's motion in one direction, then the light that's going against that direction, for example, is going to get to the receiver at a different time than the light that's moving with the same direction of motion. Mm-hmm. And this is a fact because we use these for incredible amounts of technology, bro. This is how we measure motion.
Who's we?
The whole world. Mm-hmm. This is how we measure motion.
Well, listen, the whole world knows what an accelerometer is. The whole world knows that when force is applied to matter, we get displacement. What's it? So when there's an acceleration present, we get a displacement of different matter, solid, liquids, and gas. Because listen, learn something. There's no force known to man that can accelerate gas, liquids, and solids simultaneously without displacement. What's it? So when I
get what you're saying.
When I let a bottle go in free fall and I see no displacement, that means there's no downwards acceleration.
That doesn't mean that. It means that the buoyant force is stronger. And you say
the buoyant force from where? The buoyant force from where?
The interaction between the object and the medium results in pressure mediation, and that resultant effect is stronger than the downward bias.
So,
do you agree to the downward electric current on the Earth?
There's electrical current in the Earth, yes, right? So let's go back to
what you just said. Is that electric? Do you agree to the downward electric current on the Earth?
There's electrical current in the Earth, yes, right? So let's go back to what you just said.
Is that force?
Let's go back to what you just said a minute ago. Your claim is that there's a uniform downwards acceleration of the gas light. So it was the buoyant thing, that was it, right? So if I've got the bottle that somehow is affected by buoyancy in the air, I would imagine, or by me holding it, I don't know what your thinking is. So when I'm holding this bottle, there's an air bubble rising in there, and there's something sinking, and there's air at the top, and there's liquid at the bottom. Now when I let that go, the air bubble stops rising, and the thing that was sinking stops sinking. So what was the buoyancy or something? How did it make the air bubble stop rising and the thing stop sinking? So it's a force now that's acting. Because wait a minute, the force now is acting in two different vectors. The force now is stopping an upward vector and a downward vector, and then simultaneously moving it all downwards. Is that what you're saying?
I didn't even follow what you just said. Well, there was a downward electric current on the Earth. Okay, you said that. Well, I asked the question. Answer the question. Is that a force?
Does it cause motion?
Well, of course it does. It's a downward electric current.
Where's it causing the motion?
In the atmosphere.
So what's it moving? What is it moving?
The air itself moves. The air itself is affected. There's a current, you can run a generator with it.
Right.
So the actual charge itself is moving, right? That's what a current is. So I'm asking you, so if there's a downward electric current on the Earth, right? Then we have a downward force on the Earth. It's 10 microamps per square meter. It's very small, but it's measurable and provable that there is downward electric pressure on the Earth. Right. So if for your whole argument to exist, you have to claim that's not there.
No, I don't. You're the strong man. Nobody's denied the electrical current or any of that stuff. Not once has it been denied. Over and over and over again I've stated it. What I'm fucking saying to you, Witsit, is you're claiming that there's acceleration downwards of the gas and liquids without displacement, and I'm asking you to justify that.
There's a point relationship, right? And that results in pressure mediation. In fact, the pressure mediation is actually the cause of what we call buoyancy. Right? And if you're saying that force is just motion.
So if you know the cause of buoyancy, listen.
You have to interrupt because you know.
Well, no. If you claim you know the cause of buoyancy, then I'm asking you to invert it, manipulate it.
You said that force is motion, and then you said that buoyancy is motion, and then you said that buoyancy is not a force.
Buoyancy is an effect of motion. That's what I said. Okay. That's what I said. But what's it? You can rewind it.
Then if it's an effect of motion, what exactly is buoyancy? Then what's the effect?
It's pressure mediation due to the motion.
Oh, due to the motion? No, the pressure mediation causes the motion.
No, it doesn't.
Dude,
yeah,
buoyancy is the displacement of objects relative to their densities, thus pressure mediation. So your own position contradicts itself. You say buoyancy is not force, force is just motion, but buoyancy is
let's clarify that. Let's clarify that then. So if we're back to relative density disequilibrium, then if I've got a bottle with liquid in it and an air bubble rising and something sinking and I let that go in free fall, it should continue to rise and sink within the medium. But it doesn't. It stops its motion.
But there's a buoyant relationship.
What do you keep saying that? You keep saying that. A buoyant relationship between what?
The object and the medium.
Right, so the bottle, the solid bottle and the air that's surrounding it.
No, we're talking about inside the bottle, right? Are we talking inside the bottle?
Alright, so what changes then? So for one thing, as soon as I let it go in free fall, there's no pressure within that medium anymore. None. Right? So what's causing the air bubble to stop rising and the thing stop sinking?
Say again.
There's no pressure. When I let something go in free fall, there is no pressure within the medium anymore, within the bottle. The pressure goes. Right? So if I'm holding that bottle and I've got an air bubble rising and a material sinking within the bottle and I let it go, nothing changed about the density of the water, nothing changed about the air bubble, nothing changed about the density of the matter sinking. Why did it stop sinking and why did the air bubble stop rising? Nothing changed.
Okay. Yeah, it's in free fall.
And
in order for you to make your claim, you have to claim a kinematic and dynamic equivalence. You have to claim a kinematic and dynamic equivalence of the Earth being stationary and something falling down to it, or the object effectively being stationary and the Earth moving up to it.
I'm not claiming that the objects are stationary and the Earth's meeting them. I claim that the objects are in motion and lose that velocity.
Okay, but if it's in motion in tangent with the Earth, then relatively speaking, it isn't moving. Okay, it's called relative motion.
Oh, I know about relative motion. I just quoted my own video. What's it? But see the thing about I quoted about my video. See if I had an air bubble and water on one of the rulers and I moved that ruler, you would see physically that there was motion of the ruler because the gas and the liquid would displace. What's it? Right?
Dude, your ruler experiment or demonstration literally invokes relative motion. You understand that?
That's you just invoked that. I'm just clarifying it for you.
Oh my god.
What's that? What's that?
You're saying you wouldn't be able to tell the difference in what was moving? That's called relative motion.
But what did I say? If I attached an air bubble and a little vessel of water to the ruler, and when I accelerated the actual ruler, you would know the ruler was the thing that was moving. Why? Because physics, gas and the liquid would displace, because guess what? That's what happens under conditions of acceleration. Now, back to the main point, when I let the bottle go, there is no displacement. Listen carefully, do you want me to show you a video? If I physically accelerate the bottle down the way, the air bubble moves towards the earth and the liquid towards the sky. Now, when I let it go in free fall, listen, when I let it go in free fall, are you claiming it all accelerated towards the earth?
You're claiming that there is a change in acceleration while simultaneously claiming that there isn't acceleration.
Oh, listen.
I asked you, I said, linear geometry measures objects falling at different rates at the same location over time. And you said, oh yeah, something like electrostatics causes it. So then you invoked acceleration. No, you didn't.
No, because I said if I had a little marble, because what Witsit's talking about is like solid pieces of matter, not gas and liquids in relationships to each other. He's talking about solid. Right, that's what Witsit's talking about now. What we're talking about is gas and liquids and the relationship between the two, or the three, gas, liquids and solids. Not individual solid matter and it falling at a different rate at any given time of the day. Which can be
so solids do accelerate down.
No.
So is there an acceleration or not?
Not down the way, no.
Okay, so then why does the measured rate of fall change at the same location?
Because there's air resistance, there's static electricity, there's magnetism, there's surface area, there's temperature, there's the density of the medium, there's varying factors in that scenario. So that the object...
That would mean acceleration, that would be...
Well, acceleration in regards... I meant downwards, I keep clarifying it by downwards. There's an acceleration in regards to a change of velocity, yes. Because the object loses its momentum that it had when it was solidly attached to the Earth.
If your claim is that the Earth is moving up, okay, and there's no downward acceleration, that applies to everything. Liquid, gas, solids.
That's right.
Okay. We can drop. Listen, there is no air resistance. It's in a vacuum sealed chamber. We drop a little BB. There's interferometry, so there's crossing patterns of lasers that scan back and forth and measure that object. That object falls at different rates at different times at the same location. You've then invoked something called electrostatics. What you're saying is that there's a change in the measured motion of the object.
No.
You can no longer. What?
There's a change in regards to it losing its momentum. Its rate of deceleration is fluctuating. My claim is there is no downwards acceleration, right? There's a loss of momentum, an acceleration, what we'll call a deceleration. So the object loses its speed that it had when it was connected to the Earth, right? And there can be different factors for that. Under conditions of acceleration, gas, liquids and solids display displacement. Now, when I let the bottle go into free fall, there is no displacement of the gas, liquids and solids. When there is a claim of downwards acceleration, when I accelerate downwards, I see a displacement of the gas, liquids and solids. But when I let it go in free fall, I do not witness a displacement of gas, liquids and solids. Ergo, no downwards acceleration Witsit. So what's happening?
Okay, you're saying that the object's decelerating, but when you're invoking relative motion, you're then having to say that's equally valid to acceleration.
I've clarified there is no displacement of the gas, liquids and solids under claimed conditions of acceleration. That's your problem, Witsit. So when I let the bottle go, you have to assert that the gas, the liquid and the solid are all moving uniformly towards a stationary Earth.
Okay, the actual change in the downward electric bias is extremely small and measurable. You're having to actually invoke it. You're conceding it. You're saying, yes, there's a downward electric current. Then you're saying that's not a force. And then you're saying, yes, the object will fall at different rates, so you're actually invoking acceleration or deceleration, which in relative motion are equally valid either way. They're the same thing from different reference points, right? That's what you're invoking.
If electricity causes motion, it's a force. I've clarified that. Now we're going over and over the things I've clarified already. Listen, Witsit, if I am holding a bottle, this is rudimentary and I need you to just go with me step by step. If I am holding a bottle with gas and liquids in it and I physically accelerate it with my hand towards the Earth, the air is now at the top of the bottle, the bottom of the bottle and the liquid at the top of the bottle. Do you comprehend so far?
Yeah, but you're claiming you know that there's no displacement, but that isn't true because the displacement would be very small in relation to the buoyant force, which means you have to have very precise measurement. So guess what I did? I invoked the most precise measurement that exists on Earth. It's
So,
called interferometry.
so there is this. There is.
We prove that objects fall at different rates at the same location. They fall at different rates at different locations, and we prove that linear interferometry does not detect the Earth moving. Therefore, you have a claim contrary to actual.
No. It's you that has a contrary claim, Witsit, because now you're saying it's so small that it is displacing, but it's so imperceptible that we can't witness it. Is that what you're saying?
Yeah, you would need measurements to support your claim that there's no displacement.
Well, gas and liquid is a measurement. That's an accelerometer. What's it?
What?
Gas and liquid are an accelerometer. Do you understand what an accelerometer is?
Yeah, actually, accelerometers, like in your phone, they use capacitance readings. Right? They actually use two conductive plates.
That's because
they measure the capacitance, and that's converted to an electric signal that they then attribute to G.
Yeah.
That's a fact.
Because of displacement.
Displacement of what?
It doesn't matter what you're displacing, because forces cannot act simultaneously on different states of matter uniformly. What's it? Right?
Oh, so clearly you brought up accelerometer. It turns out you don't know what they.
I did. An accelerometer. I've just clarified it. You just don't comprehend it. An accelerometer works because force is not multifaceted. An accelerometer works because when force is applied to a particular piece of matter, other matter stays where it is and it causes displacement, and that's how we read motion. Right? That's how we know how much motion there was. What's it? So what I'm saying to you is a basic accelerometer is gas and liquid. If I accelerate gas and liquid in any vector, 360 degrees three-dimensionally, I see displacement. Downwards, upwards, left, right, diagonal, any direction you want. Now, when it comes to free fall, we do not witness any of that. Not only that, buoyancy and density cease. Pressure ceases. Density gradient ceases. Because the motion of the Earth is no longer present. Acceleration is no longer present.
Well, that's a convenient claim.
But that's a reality.
This is like an actual stillman of your position. The Earth is moving. You just can't measure it.
You can measure it. Listen, Witsit. Listen, here you go. Right. So see if I'm holding the bottle, okay? And here's I'm playing with the variable, right? When I'm holding the bottle and the air bubble's rising through the water, and I accelerate it more up the way, guess what happens, Witsit? See the rate of the air bubble rising through the medium? It increases. And then see if I accelerate it the opposite down the way, the bottle, it now inverts and the air bubble now goes towards the earth and the water towards the sky. And I can repeat that in any vector I like. But the vector that we already have where water's level, it's already displaced, showing us the motion. If I add to that vector, I can increase the rate of the motion of buoyancy and density. Not only that, I can increase the pressure. What's it? Can you achieve any of that with electrostatics? What's it?
Is there a downward electric current on the Earth? Yes or no?
There's an electrical current, yes.
Okay, and that's not a force.
Yes, if it moves things, it's a force. If it causes motion.
Okay, so
the fact that it's moving.
Force on the Earth,
Listen.
How does that factor into your explanation of dropping the bottle?
The fact.
Just go away.
See the fact that I accounted for this about 45 minutes ago, right? Well, I guess I told you fine well. If there's motion, it's a force. So if there's motion present, it's a force. Okay? Because that's what force is. Motion. F equals ma, mass times acceleration. Something moving is what we denote as force.
There is a downward electric force on the Earth. You're claiming that doesn't result in any type of downward bias or acceleration. So now you're going to have to invoke your little bottle experiment and explain the downward electric bias that you keep ignoring.
It's not, there's no downward electric bias in regards to gas, liquids and solids. What's that what you're talking about? I've just explained that to you. You're the one listen. I use motion to display the pressure and density gradient, the motion vector of buoyancy and density, any motion vector, utilising motion, right? Displacement of gas, liquids and solids under conditions of acceleration. You are now claiming there's a bias of electricity downwards, which denotes that it must be moving the gas, the liquids and the solids simultaneously with no displacement. And what I'm asking you is to achieve that in any other vector. If you can invert buoyancy and density, if you can invert the pressure gradient, the density gradient, show me it.
Okay, and I've already told you that, look, listen carefully. If I have two plates, okay, and I put an iron filing in the plate, if I hook it up to a Van de Graaff generator, I can flip the polarity of the field and the object will go up. Even though the object's more dense than the air, it flips the equipotential surfaces and the vertical electric field, which changes the polarity of the field and causes the object to go up. On the Earth, we have a downward electric current and a vertical electric field. This creates the bias. The density relationship of the objects result in a buoyant, if you want to call it that, I don't care, and that is much stronger than that weak downward electric bias. The way that we can measure and prove that objects are falling to the Earth and at different rates is using interferometry. Your response to that was, oh, well, yeah, stuff like electrostatics or electromagnetism will change the rate that it falls, but it's not falling. You're saying that
See, the thing is,
you're saying that.
the thing is when I've spoke about these things, as I say, I'm not even doing that avenue yet. I've not even got that far, and I've continued to try and say to people, listen, there's a conversation to be had about electrostatics and magnetism, but it's not responsible for the conditions of Earth. It's not responsible for the vector, right? That's what I've been saying, right? So again,
how do you know that, bro? How do you know that? Because it's a real effect that I can measure.
Because I go with practical. I go with the practical, right? So what I'm saying to you is you need to demonstrate again your iron filings, right? That's fine, iron filings. Demonstrate gas, liquid, and solid being moved uniformly with your capacitors, your two plates. Show me that you can invert the orientation of the gas and the liquids within the capacitors. Demonstrate that, Witsit.
Okay, you would have to introduce a ton of electrostatics. I've never personally done that. But what I have 100% done is change the vector of the object, right? Simply by flipping the polarity of the field. What your argument requires is we dismiss all these other variables.
Listen, I'm going to make a point, Witsit, quick, just to clarify this for you. See if I've got a solid iron block that's sitting on the floor, Witsit, right, and it's denser than the air. But see if I put a fan under that and blow the fan hard enough so that it elevates it. Does that somehow mean that now we're talking about air blowing? Because that's exactly what you're doing with the electrical thing, right? You're elevating it like building a bridge, right? Or using a stream of some kind, like I'm just showing you with the air. That's not what we're talking about, Witsit. That's a parallel trick. We're talking about uniform motion of gas, liquids and solids, which you must have on a stationary Earth, right? You must have that. Now I'm asking that to be qualified, because my position can be qualified in any vector. I can recreate it. I can account for why buoyancy and density ceases in freefall. I can account for all these things, but you can't. You keep laughing about buoyancy, right? The air bubble stops rising, the thing stops sinking, and the whole thing's moving towards a stationary Earth at the same fucking rate. Witsit? So you need to show me in your little capacitors that you've got an air bubble rising, you've got something sinking, and you can use your electrostatics to stop that from happening. Right? Halt it!
First of all, it's not the same rate, it's not uniform. Just because you keep saying it has to be doesn't mean anything. The fact of the matter is that you are ignoring objective reality when you're saying, yeah, no, you are, because you have measured objects falling at different rates at the same location.
We've talked about that.
Earth moving up. You have to say the Earth is moving
we've spoken about that,
different locations at different times. or you have to invoke something. This is what you're saying. Well, yeah, sure, there are other variables that affect how we perceive something falling, but I promise there's something else before that, which is the Earth moving up. Just take my word for it, even though we can't directly measure it.
I mean, I'm measuring it's measured every single day. You can set an accelerometer.
That's called a reification.
You can set an accelerometer on the table, right? It's not a reification fallacy, it's certainly not. That's you that's reification fallacy, because you're taking a parlour trick and trying to superimpose it onto everything. And I'm clearly stating for you that you need to be able to achieve the things that you're claiming, and you can't. You keep saying, oh, I'd be big enough. This sounds exactly like globe Earth. Well, I could recreate gravity, but I need a planetoid. I need a big enough mass.
So I've already replicated it, dude.
Where's...
If I manipulate the variable of electrostatics, I can change the vector of an object.
I can change...
not even detect the alleged motion of the
I can change the vector of a solid object with air.
Assume it, and then you redefine and affirm the consequence.
That's you that's doing it. That's you that's doing that, Witsit. That's not me. I can elevate a solid object with air. What does that prove?
Dude, listen very carefully.
No, you listen. I can elevate a solid object just the same as you can with your Van de Graaff machine by using air. So what?
Yeah.
And?
Okay.
So what does that prove?
That's totally irrelevant.
No, it's not. It's because you're avoiding the thing. Witsit? Can you invert buoyancy and density? Can you halt buoyancy and density?
You knew I was about to answer you.
No. But I've been asking the same question for the last hour. Can you invert buoyancy and density? Can you cease buoyancy and density in the motion vector using a Van de Graaff machine or whatever you like? Can you achieve that, Witsit? Because that's what we observe in reality in freefall. And if you're claiming that that's what's the cause of it, then I should expect you to demonstrate it on a smaller scale. So can you demonstrate it? Yes or no?
Okay.
The answer is no, you can't. No, you can't demonstrate it, Witsit. So it's no reality then, son.
Okay, so I'm really trying to follow you. I'm not even trying to be a jerk. I'm trying to follow you. But this is the facts of the matter. There's a downward electric current on the Earth.
I know.
You admit that it's a force, but then you're claiming that whenever we drop an object, that there is no downward force affecting the object falling.
How does something stationary have a vector in the first place? How does something stationary now have some magic force that accelerates gas, liquids and solids towards it without displacement? Have you recreated that?
How is it a magical force when you just conceded it exists?
Because you're claiming it can do things that it cannot. That's the magical part of Witsit. Now I'm going to ask you again. Can you invert it? Can you halt buoyancy and density in their motion vector? Can you cease the pressure within the medium? Can you do any of that, Witsit?
you can absolutely invert the vector of an object.
That's not what I'm asking you, Witsit. Can you invert buoyancy and density motion vector within a medium with your electrical field? Yes or no? Answer, no you can't.
I'm not going to say no. You would need a strong electrical...
I can show you gravity, but I need a big enough planetoid in outer space in order to show you.
No, I never said that.
It's the same thing. Same thing.
No, dude, you want to know what the same thing is? You're claiming the Earth is moving, but you can't directly measure it.
It's measured every day. I'm measuring it right now. I can feel my own weight.
Oh my god, your own weight is you measuring the Earth is moving.
Well, what's causing my weight?
Okay.
What's causing my weight? What's it? Here we go. Another bit of intellectual insight. What causes my weight? What's it?
Okay, so weight equals mass times quote-unquote gravity, which is obviously just downward acceleration.
No.
Volume times density. Volume times... Don't ask me a question and then not listen.
So you're invoking gravity now. What's causing my weight? What's causing water to be level? What's it?
Wasn't I trying to answer?
What's causing a plumb line to be straight down? What's it? What's causing water to displace level? What's causing my weight? What's causing my direction? What's causing the motion of buoyancy and density? What's causing the directionality? What's causing all that? What's it?
Are you done freaking out?
What's the cause of weight? What's it?
I'm trying to answer, but you're...
Don't say gravity, because gravity is just the motion of the earth.
Oh my god, dude.
What's
so, the quote-unquote gravity, which is actually just acceleration, which is an agreed-upon average of things falling. We measure with interferometers, and how much retarded people on the internet with 180 viewers say nuh-uh. So the reality of the situation is that weight equals mass times gravity, but actually mass is just volume times density, and quote-unquote gravity is actually just little a, downward acceleration, agreed-upon average, which is not uniform, it's not constant, it fluctuates, okay? So your weight is going to be based on volume times density. What is density? The compactness of matter. What's the cause of the compactness of matter? What's the cause of the compactness of matter?
Density is another concept. Again, we'll get two options. What's it? Is it me pressing down on the earth or the earth pressing on me?
I'm pressing down on the earth.
So downwards acceleration.
Yeah, I just...
Right, exactly. Right. No, you're not measuring it. What's it? No, you're not. Right, again, what's it? Downwards acceleration. Gas, liquids and solids don't displace in free fall when there's a claim of downwards acceleration. There we go. It took an hour for Witsit to actually categorically state that he doesn't claim downward acceleration, but then he just stated it.
Everything you say is strong. I never said there was no downward acceleration. I said there's no constant uniform downward acceleration. Okay, whenever I said quote-unquote gravity, actually that's acceleration, and you said, oh, you're invoking gravity now? No, I specifically didn't, did I? Whenever the people in the chat say, oh, remember also said that buoyancy causes itself. No, I didn't. I said pressure mediation. I said pressure mediation. Everything that you're saying is strong.
Let's clarify pressure. Let's clarify pressure mediation. What do you mean?
Okay, pressure mediation, which is pretty tricky actually, but things intrinsically. What?
Nice. Go for it. What's pressure mediation? Go. What causes pressure?
Okay, well, pressure is force over a certain area.
What's force? Motion. So let's. I just want to know. I need to stop you. So when we say force, we mean motion, correct?
Mass times acceleration is how we define it.
Yes, that means motion. That's simply put motion. So what's it saying that motion is what causes pressure, correct?
Again, it's quote-unquote mass times acceleration, which is actually volume times density times the agreed-upon average in which we measure things falling.
Motion, aye.
It's yes, something in motion is caused by a force.
And a force.
It's not that the motion is the force.
What's it? In order to make something move, something has to move towards it. So motion makes motion. So something has to press on something else. So something has to be in motion to press on something else to make it move. So motion causes motion. Correct?
Motion causes motion.
Yes. Because you're defining force as motion. That's what F equals ma is.
Density is actually the compactness of matter. So all molecular and intermolecular attractive forces are electrostatic in nature that actually holds the matter together. So based on that actual relationship, you have a certain compactness of matter, i.e. density. That density has a relationship with the medium, and then that actual relationship is exchanged with electrostatic induction and transference. All provable and measurable, by the way. That results in pressure mediation, meaning the actual charge, right? The charge per volume is actually responding to the charge per volume in the surrounding medium, and then it then begins to equalize. It equalizes based on capacitance, which is the threshold for electrical storage. So if the system has too much storage or too much electrical charge for its threshold or capacitance, it begins to discharge. People call that negative charge. Then you have positive charge. It's charging up because it hasn't reached its threshold. This relationship is actually what causes pressure mediation.
The motion again, and the discharge is just motion again. Again, you know, that whole word salad that we just had there was loads of things said in there that you can unpack, right, and assumptions being made and stuff. Listen,
You're just like a clover,
No, you're the glober. You don't learn and your ego's overtaking you. What's it? You've got these mantras and these written statements that you just like to waffle on about, but you don't pay attention. And I told you, you're up against it here, son. Right? So we've established, right, that the real people, the ones that are actually rational and sane, we know that when we're talking about force, we're talking about something in motion. Because that's what it is. That's what the whole foundation of science is. That's what we observe as change. And a change is motion, Witsit. Right? Now, in a medium, in free fall, there is no pressure. Do you comprehend that, son?
No, I just absolutely destroyed you, and your response was word salad.
No, I'm not. You've been asked to demonstrate how you can invert C-smart buoyancy and density in its motion vector. You've been asked to invert the pressure and density gradient, which you cannot achieve. You say things like, I need a big enough capacitance and all this stuff. You don't comprehend. You don't
even understand.
Well, can you demonstrate that? Can you demonstrate
so
that?
arrogant and not even understand.
No, it's arrogant. Can you demonstrate what I've asked you?
Let's summarize the conversation. You admit that objects fall at different rates.
See you later, son. I've got things to be doing with me.